This is Note Taking Guide 6.4 for Mathematical Decision Making for Life. So what we're going to be doing today is we're going to be looking at some graphs, some data, some displays, and decide whether or not these have any kind of bias in them or whether or not they're truly depicting what they're supposed to. So here's this example right here that's talking about the hockey players here, and I just want to look at the graph here for just a minute before we even read anything about it. So I want you to notice on this graph up here that this is the all-time Stanley Cup playoff leaders. And Wayne Gretzky, he's the all-time leader. And he's up here at 380 points. I want you to notice right here that Mike Messler, he's down here at like, what would you say that is? Maybe 290. And then Carl Curl, he's down here at 230. Glenn Anderson is right under 230, so maybe 220. And then Paul Coffey down here, he's maybe like 200 if we were going to kind of guess what he was at right there. Now I want you to look at this data and I want you to decide whether or not this graph is really displaying it the way that it should. So I'm looking at how small this guy is over here. Like he is super small and he's at that measurement of 200. And then Wayne Gretzky, he's over here and he's super tall and he's at a measurement of 380. So in my mind, down here, if this is at 200, then Wayne Gretzky should only be twice as big as 200 to be at close to 400. So can you see how this data is kind of skewed by the way that it looks? So let's come back over here and let's look at the questions and see what's going on with this. It says, according to the size of the hockey players, how many times more points does Mike Messier appear to have than Jari Kurri? Explain. So right here, if you're looking at Mark and you're looking at Jari is this tall, and it looks like if we doubled him, then he would be as tall as Mark. Do the numbers show the same thing? No, he's at 230, he's at 290. If we double Jari, then he should be way up there at 460. So again, the pictures on this graph are not depicting the information correctly. This is a biased graph. It's trying to make you see how amazing Wayne Gretzky is compared to the other players, but really their numbers, at least these guys right here, are all very similar to each other. So the graph is kind of depicting something different than what the numbers are actually saying. So number 2 says, do you think this graph is representative of a player's numbers of points? And I would have to say no. Like graphically, this should not be such a huge change from down here on Paul to up here on Wayne Gretzky. They should be quite a bit closer together. So that's what we're doing today. We're kind of analyzing graphs and looking at them and deciding whether or not they have problems or if they're fine. So this next problem just says, misleading graphs are sometimes deliberately misleading, and sometimes it's just a case of people not understanding the data behind the graph they create. The classic types of misleading graphs include cases where the vertical scale is too big or too small, or skips numbers or doesn't start at 0. So what is the vertical scale? It's these numbers that go along the one side of the graph. So sometimes they don't start at 0, sometimes they skip numbers, sometimes they're not counting by the same amount of numbers. That's what that's kind of saying. Sometimes the graph's not labeled properly, and sometimes data is left out just to make you see something differently. So again, let's just zoom in a little bit and look at this example here and see what it wants us to notice. So school dances. The graphs show how the price of the spring dance tickets increase. So from 02, they were right under $4, it looks like. 03, under $4. 04, up there around $7, $8, and then up here to maybe $9 or $10 right there. Okay, graph B shows actually the exact same data. Look, at 06, we're up at $10. At 03, we're down right there at 4 or 5, right below $4 or $4, which is what this other data is. So the data is the same on each graph. So why do they look so significantly different? Well, the reason they look significantly different is the way that we counted on our vertical axis. If you noticed over here, we realized that we were only dealing with numbers between like 2 and 10. So we counted over here by 2s and just kept our numbers short. Over here, they counted by 4s. And when they counted by 4s, it made our data be scrunched together, so much closer together. So it looks like it's not changing as much here. And on this graph over here, it looks like it's changing drastically. All right, so let's answer the questions. Do these graphs show the same data? They actually do, even though they look completely different. Which graph makes it look like the prices are increasing more rapidly? That would be graph B, because graph B looks like it's going crazy up fast. That slope is changing quickly, so it would be graph B. All right, let's look at the next one. All right, this says identify the bias displays. Fitness. The president of a large company mailed a survey to 500 of his employees in order to determine if they use the fitness room at work. The results are shown in the graph. Identify any sampling errors and explain why the sample and the display might be biased. All right, so let's look at this graph over here real fast and just kind of see what's happening. Well, clearly, a lot more people are using the fitness room than not using the fitness room. If you remember, they said that they asked 500 people. So one of the things we should always do in statistics is to check to make sure our numbers add up to be 500. So just really quickly, look at these two numbers, 338 and 116. Those two numbers do not add up to 500, which means that this graph right here is not going to be displaying accurate information because it doesn't add up to the number that it's supposed to. And that's kind of what it explains down here. It says not all of the surveys were returned. 338 plus 116 is less than 500. This is a bias voluntary response sample. The sample is not representative of the entire population since only those who wanted to participate in the survey are involved in the sampling. The display is biased because the data used to create the display came from a biased sample. So because this didn't use all of the people sampled, it doesn't actually show the data correctly. All right, so just another thing to look for, make sure that your numbers are adding up to the total that they're supposed to in order to be correct data. Okay, last example here. It says misleading statistics. Refer to the table that gives the height of roller coasters at an amusement park. The park boasts that the average height of their roller coasters is 170 feet. Explain how this is misleading. So take a minute and look at that data and see if you can see why that data is misleading. It says that the average height of the roller coasters is 170 feet. Well, this roller coaster is 109 feet. This roller coaster is 135 feet. This roller coaster is 115 feet. Then this one's huge. It goes up 365 feet. And then this last one right here, 126 feet. When you look at that average of 170 feet, look at how many of those roller coasters actually go above 170 feet. Only one of them. So because this number right here is such an outlier, it skews that data. And we already talked about that the other day when we were doing mean, median, mode, and range. That outlier skews that data so badly that the average is ridiculous, when really the average should be more around, closer to those numbers that the other four roller coasters are in that range for. So how is this misleading? You could just write here, only one roller coaster is higher than 170 feet, which is the average. So that is why this data is misleading. So what you're doing today on your assignment is you're looking for misleading information or part of the graph that causes it to not be good information. You're looking for bias again is really what you're doing. Thank you guys for watching. Good luck on your homework.